So good morning, everyone. Now that we've already given a couple of minutes for other folks to join in, we'll go ahead and get started with the live webinar. My name is Alberto Diaz. I'm a project manager here at VisualAIM. I'll be giving most of the presentation, but we also have Ed Moens with us. He's the president of the company, and he might also interject at various points throughout the presentation as he sees fit. And I just also want to let you know that as part of the Zoom features, I can enable you to talk, and all of the attendees that have been joining in have been enabling that capability. So if throughout the presentations you've got any questions that you like to ask, the only thing that you've got to do is click on that unmute button within your Zoom options, and you'll be able to speak throughout the presentation if you've got any questions or comments that you'd like to bring in. So by all means, feel free to interject when you have any questions that you might want to ask. I'm going to go ahead and first of all bring up here my laser pointer. So today we're going to go over essentially one particular project that we completed recently. This was a full mechanical integrity migration that we did for a client here in the United States that involved the migration of 8 of their process manufacturing sites to our cloud-based mechanical integrity system. And I'll give you a couple more details within the next couple slides, but it's essentially going over the work process that we completed with them in order to fully migrate all of their inspection data management system and risk-based information from their databases over to our cloud-based solution and deploy that across the 8 manufacturing sites. And we just want to do this in order to share with you some of the lessons that we learned throughout this process that we are definitely going to implement moving forward, and we think they could be of value for you to understand what were some of those hurdles that we faced throughout the way that could be also of value for you to know as well.
Alberto, just really quick too. It was a U.S.-based corporation, but it's a global company, and that added to the interesting pieces of knowledge sharing with the folks in Shanghai and the folks in Rotterdam. So anyway, so go ahead.
Absolutely. So for today's presentation, I'm first going to go over a quick overview as far as the project, the reasons for migrating over to VisualAIM, and then ultimately the result that was obtained from that. I'll also review the cut-over plan that we went through with the customer and some of the key steps that we believe we should have potentially honed in a little bit better at the beginning to kind of make the whole process a little bit more streamlined from beginning to end. We'll also dedicate a whole slide to data collection because this is one of the key processes for any mechanical integrity project, regardless if it's a data migration or if you're starting from scratch. So we want to share some takeaways there. Then we'll share with you some of the performance improvements that the company ultimately realized by migrating over to VisualAIM's mechanical integrity solution, and also some metrics and bulletin boards that we put together in order to enable the knowledge transfer within or across the facilities globally. From a project overview standpoint, and as I previously stated, and as also Ed mentioned, this is a global company. They've got manufacturing sites in at least 4 or 5 countries across the globe. And the objective was to migrate their both inspection data management system and RBI databases over to VisualAIM's cloud-based mechanical integrity suite of modules. Now, what was the primary idea behind doing this? It's because the company was managing essentially 2 separate solutions, one for inspection data management system and another one for RBI, and they had to be updated in parallel for their mechanical integrity activities. VisualAIM has both a risk analysis and an IDMS module, both integrated into the cloud-based solution. So you basically eliminate one redundant system such that you only manage one program moving forward, and all of the modules are integrated. So in the original scenario, you've got 2 separate software systems that you've got to update individually, versus in VisualAIM, you've got a single unified solution that talks within its modules for you to, you do the update on the NDE side, and it automatically talks over to the risk analysis in a streamlined fashion. So that was the purpose or the reason behind migrating over to VisualAIM's mechanical integrity platform. Now, the main challenge was, of course, the fact that a lot of these solutions were all locally based in each of the 8 manufacturing sites. Some of the sites use one of the solutions, others use 2 of the solutions, and we even had some instances in which there were actually 3rd or 4th database repositories separate from the IDMS and the RBI that also hosted mechanical integrity information. So the real challenge for us was to consolidate all of that into our cloud-based platform. But at the very end, the result that we got was essentially one centralized cloud-based solution that contained the IDMS, the RBI system, and also these 3rd and 4th lagging databases, also with mechanical integrity information. But of course, this was a very technical oriented type project. We did hit some hurdles along the way, and moving forward, what we're going to share with you is the key takeaways that we think that if we would have maybe approached a little bit differently from the beginning, we would have gotten better results as far as completing the project more effectively. So starting from the very beginning, when we talk about the cutover plan, we really think that the kickoff or the initial step of the project is essentially extremely key. And we would have definitely, when starting a new project of this fashion, focus more on this step of the process. First and foremost, clearly reviewing with the client what the migration plan is going to be with the main stakeholders. The importance of this is because, and especially given the fact that this involved 8 facilities and multiple sets of databases, we would have clearly liked to better define with the stakeholders what each of those steps were going to entail and the potential issues that we might have come across. That's why also as a part of that review, we clearly want to define with the client what the deliverables and acceptance criteria are for the software, because you could potentially fall into the rabbit hole of basically developing additional or more items as you go along the migration process that perhaps were not part of the initial scope, based on additional things that sort of start to come up as you do the migration process, as plant personnel start to test out the software. So you really want to hone in and clearly define what the deliverables and acceptance criteria are going to be for the migration, such that you don't get to that particular pitfall. And as a part of that, you also want to at least try to identify what would be the potential difficulties and discrepancies that you might find along the way and what those resolutions might be. One clear example of this when doing this data migration is that you're obviously going to have certain data gaps. From the beginning, you want to clarify who would be essentially the responsible or owner of that particular difficulty. Is it on the customer side? Is it on the technology vendor side? Because depending upon this, again, you could fall into certain conflicts down the line that you don't want to. That's why you gotta try to identify what these difficulties might be at the very beginning of the project and define, hey, if we find a data discrepancy for this particular reason, it'll be on the side of the technology vendor. However, if it's a data gap that existed, prior to the migration process, it'll be on the customer side to take care of this particular data gap or data discrepancy. That's going to just make everything down the road a lot better and clearer as far as who has to solve what and what ultimately the objective is and the deliverable is that's going to close out the project. Also, you want to state all potential assumptions of the project. If you have multiple databases, you want to make sure and understand that let's state that the assumption was that all database structures would be the same across the 8, 10, or 15 facilities. This might not be the case when you actually start looking into the actual data and the different versions of the programs across the different facilities. So you also want to state these assumptions such that if a discrepancy shows up, again, throughout the project, you're able to state, hey, at the beginning of the project, we defined that we would assume that all database structures were the same, but we perhaps got to one data structure that was different. So clearly defining that at the beginning of the project definitely helps a lot. And we would say that one of the main and key steps is definitely to find yourself a project champion if you can. What we mean by a project champion is a representative within the company to which you're supplying this data migration on the customer side, who's basically the linchpin or the key individual who is able to understand both the vendor side and the customer side and kind of cut through all of the different loopholes that can come up around the process to basically make it happen. And this is the person who's gonna essentially be your flagship individual for the adoption of the technology as well from the customer side. So if you can find a champion early in the process, this is definitely probably the single most beneficial step you can do early on in the project scope. Once all of these points are clearly defined at the beginning of the project, then you obviously start with the data transfer. I've only included a couple of bullet points here because we dedicate the next slide completely to this particular point, because this is obviously the biggest step in any migration for mechanical integrity. And I put in the first bullet point migration versus import, because depending upon the nature of the project itself, you're either migrating information from existing databases, which is essentially what we did in this use case that we're discussing, versus you could also have the perspective or a project in which you're basically starting from scratch. You're importing information from scratch into the mechanical integrity system. So in that case, the approach is similar, but slightly different in the sense that you first have to define who's going to be doing the data collection and who's going to be importing that into the system. But we'll talk a little bit more about that in the next slide. As a part of this, you of course have to identify what the data sources are and make it clear for the customer, if they're heavily involved in the data collection process, where to find the information that has to be collected for the RBI study. And this information is mapped into the VisualAIM data structure, imported into the software, and once that step is complete, you essentially pass to the third step, which is also crucial, which is that of acceptance testing. The main thing that we as VisualAIM do is that we actually, depending upon the scope of the project, we always like to grab a statistically significant subset of assets to test the software calculations on. So let's say the particular project involved, 10,000 assets. We'll grab a representative sample of, let's say, about 50 or 100 assets across the different asset types within the portfolio and run the calculations within the software after the data migration has been completed, just to ensure and validate that the calculations are all correct with respect to the version of the standard that we're managing. That way we can validate for both for ourselves and the customer that the results that we're getting from the software are the accurate ones, and this just increases the confidence that we can get from the customer side as far as the migration goes. Once that is complete, then we go ahead and train the plant personnel. Typically speaking, we do this in a virtual fashion, especially at this moment in time. And this is just so that all plant personnel have a clear understanding of how to utilize the software, which kickstarts the trial period for the platform. So all of this takes place inside of a development database so that all plant personnel can go in, test the software, change information without it affecting the actual mechanical integrity source data. This is just from a trial period. Typically, it'll take a couple of weeks or even a couple of months, depending upon the complexity of the project and the number of facilities that are involved within this process. And by the end of it, you typically get obviously feedback from the client, suggestions as to how to make the software a little bit better. But ultimately what you get is the client's confidence and acceptance saying, yes, we're confident with how the software works, its utilization, the calculations, and we basically want to move forward and go live, which is the final step here in the process. Once you go live, you migrate all of the source information from the development database, you freeze it, and basically flip the switch on what's called the production database. And from that moment on, then everything is handled by the client, essentially speaking. At which point, we typically go ahead and also put together a help desk or basically a support system such that any questions that arise after plants have gone live, they can go ahead and submit these questions through a ticketing system that I'll show you later throughout this presentation. And it just allows for that support system to be in place in case any questions come up or suggestions are made as far as how to make the software function better. At this point, there's also a closeout meeting held with the customer. This goes back to the first point that I talked about with respect to defining deliverables and acceptance criteria. You always want to have a closeout meeting to make sure that basically all of the checkboxes are marked, so to speak. Everything that was defined at the beginning of the project and stated that would be part of the deliverables are clearly accepted by the client. And now everything is in production, good to go. We'll also talk about this bulletin board a little bit later, but this is something that we put together to increase the knowledge sharing across the facilities. With this bulletin board, people from the multiple facilities can look into the different metrics of each facility and also understand if there are any particular hurdles or even improvements that are being suggested for the platform. It can all be visualized through this one centralized bulletin board for visualization across all facilities. And any suggestions that are posted for the software and that are programmed into the platform are then sent out as scheduled updates to the cloud-based platform moving forward in a much more either monthly, bi-monthly, or biannual fashion to send out those updates out throughout the facility. And that's essentially the four main steps of any particular process, but we just like to reiterate the fact that the kickoff setting, all of these points of reviewing the migration plan with the stakeholders, defining the acceptance criteria, and finding a champion, we would hone in as saying that these are the main steps that you want to make sure you align yourself properly with the client at the start of the project to make the data transfer process as streamlined as possible. Now, when we talk about data transfer in particular, oh, and this is just one more thing. As part of this project, we've obviously went ahead and refined our data cutover document protocol much more within VisualAIM. And this is just a sample of the document. It's not the full document, but we now have got this full protocol that we go through each client whenever we're going through a migration process with them. We go through each and every one of these bullet points to ensure that we take these lessons learned into consideration moving forward. Now, when we talk specifically about data collection, and as I stated before, depending upon the nature of the project, you're either going to be migrating data from existing databases, which is, again, the use case that we've been discussing from the beginning of the presentation, or you're collecting the information from scratch, right? So the key takeaways that we got from this project that we completed with the database migration are stated here below. The first one of which, and this goes back to, again, stating the assumptions of the project ahead of time. We had the issue that the 581 risk-based standard that we utilize in our software platform is actually newer than the version that was being utilized by the customer. So this version difference brought in one particular inconsistency, and it was that sometimes we would have data gaps because in the original or the previous version of the standard, you wouldn't have the requirement of a particular data point. Let's say, for example, the confidence data on the thinning damage factor calculation versus on the updated version of the standard that we were utilizing in the software, that was a data point requirement. So you would see a lot of data gaps occur in that sense. It's not that there was a data migration issue, it just was the fact that the standard was a difference. So from that point of view, what we ended up doing was providing options for the customer to default sets of values for the software. This was an example. Another example of a default value could be, for example, the atmospheric condition for the calculations. It typically asks if it's a temperate climate, a desert type climate, or if it's close to any marine sort of condition. So we had to add in those preset default values for the customer to select depending upon the region of the particular facility in order to facilitate this whole data migration and data gap closure process, which also is a part of it. We have a number of scripts that we run throughout this data migration process to validate, for example, the units of measure, make sure that, you know, if you're putting in some sort of thickness, the fact that it's in some inch, feet, or millimeter type measurement, versus you want to make sure that you don't have some sort of volumetric item over there. And even other parameters, such as if you imported, let's say that the data that you're bringing in from the existing database systems stated 100 psi for the design temperature, and then on the operating temperature you have 150. Let me state that again. In the parameters for design temperature, if you have 100 degrees Fahrenheit for the design temperature of a particular asset, and the operating temperature comes in as 150 degrees Fahrenheit, we have scripts and special codes that tell us, hey, it's flagging the fact that you're putting an operating temperature that's higher than your design temperature. This is flagged and sent back for review to the customer. So all of these different things we were able to provide in a report format for the client to review, and basically close the gaps of these information discrepancies on their end before we uploaded this database structure into the VisualAIM mechanical integrity database structure. And once that process was complete, everyone was happy with respect to the data that was being imported. Once everything is up and running inside of the system, we also have this data validation tool or utility within the mechanical integrity software, which actually tells you what data gaps you might have. So if you add an additional piece of equipment or activate an additional damage mechanism within one of the previously existing equipment, if you run this validation, it'll tell you what points of information or data gaps you have. That way you can obviously import it into the system at that point and rerun the calculations. As stated before, when you're starting from scratch, you're now talking about data collection instead of data migration. As I mentioned, this process, the scope that we had for this particular project was a data migration, but we've worked with some other customers in the past from a scratch point, essentially speaking, and there's some other takeaways that we'd like to share from that perspective. One of the main takeaways being that you really want to train basic API 581 concepts to your customer, and in particular their technical services team. We state this because in this particular project that we're referring to, the data collection portion was heavily performed by the customer. And at the early stages of this process, they were not super familiar with the API standard. So there was a lot of questions with respect to even, if I have a vessel, what components should I take of that vessel? What level of detail do I have to have? Even like the support is a particular component. Am I just sticking to a shell and head? Those sorts of questions. So if you're able to train on these basic concepts of the API very early on the stages, not only of the data collection, but of the entire mechanical integrity process, you'll have a lot more success. And when I say this mechanical integrity process, I'm just going to pop up here for a second the work process that we typically use when implementing our mechanical integrity system. And this particular work process is indifferent of the technology that you're using. Regardless if you're using the VisualAIM solution or some other mechanical integrity solution, you will typically follow these steps all the way from defining the scope of work to the data collection of the equipment. Throughout this process, especially as just stated right now, if the customer is heavily involved in collecting the information of the assets, you want to make sure that they get sort of like a constant on-the-job training to understand the basic API concepts, where the data is going to be coming from and everything, to ensure that the data that they're putting together is as accurate as possible, and it's going to require as little rework as possible throughout the mechanical integrity implementation. Which obviously brings me to my next point, ensuring the data sources are understood by the customer. This is something that we achieve by, in the data import sheets that we provide to our customers, we typically provide an additional point of information on each of the data points stating where they would typically find the piece of information. So as an example, on a construction date on a vessel, you'll typically find that on the U1 documentation or any construction document. When you're talking about, for example, storage tank versus operating pressures and temperatures, you can typically get that from any data historian. If you go out to the field to look at the actual temperature and pressure gauges, looking at HISIS models or even the SCADA system, depending upon the level of control that the facility has, you can go ahead and grab this information. But again, it's very important for the customer to understand where these data points typically exist, so that they can, in a much more effective manner, go out and collect this information. With regard to the whole mechanical integrity process, you typically also perform a corrosion study when, after you've defined the scope of the assets that you're gonna perform the RBI study on, you typically perform a corrosion study to understand two things, basically speaking. One, the different damage mechanisms that will be present in each component, and also the different corrosion rates that would apply to these particular damage mechanisms. If you're able to finalize this corrosion study early in the process, it's going to be more effective with respect to a data collection perspective, because depending upon the damage mechanism susceptibilities present on the particular assets, you're going to have different requirements for the data that needs to be put into the system for the calculations. So if you can also ensure that this corrosion study is performed early throughout the mechanical integrity work process, you can also ensure that when the technical service personnel go to collect the information for the assets, it's much more effective, because you're targeting also the information needed for those damage mechanisms. At the same time, and as spoken before, when you do this on-the-job training, you also want to make sure that the customer gets the software training as well. So not only the API concepts, but the actual utilization of the software as well. This is just going to enable them to in a much quicker fashion, adopt the technology, become familiar as to how to use it, import the information, even import the information themselves, perform risk analysis, import NDE or IDMS data for thickness measurements. And it just makes the whole process a lot more streamlined when you get to that very end point of acceptance testing and transitioning over to going live. By having that on-the-job training for the software, it really increases the confidence on the side of the customer that they know what they're doing, that they're confident with the technology, and that they want to move forward with a quick adoption of it. And as stated before, within the software, we do have a data validation utility. So even after the data is imported, if there are any gaps, the software will clearly tell you where those gaps exist, and will actually prompt you to fill in what those missing data points are in a very streamlined fashion. So it just goes to show that whenever you're doing a mechanical integrity process, regardless if it's from a migration or if you're starting from scratch from a data collection standpoint, you really want to have these takeaways and basically transfer as much knowledge as you can to the customer, to both increase the confidence that they have not only in your technology, but in the overall process as well, and make the whole acceptance testing phase of the process a lot more streamlined. With that said, I'm just going to transition over now to my next slide, which talks about performance improvements. So after we completed the migration process, acceptance testing, and the personnel across these 8 sites started to utilize our mechanical integrity system to the full extent, they found that they were basically seeing up to 50% execution improvements on field inspections, in particular when it came to external visual inspections. The 3 images that I'm just showing up in the screen now are some screenshots of our external visual inspection application that VisualAIM developed that directly communicates with the mechanical integrity system. This application has the capability to perform these external visuals on piping systems, storage tanks, and also pressure vessels, and it follows that very same format present in each of the appropriate standards for those asset types to basically jot down or report any sort of issue with regards to general points, corrosion, leaks, and whatnot. And our application just allows you to very quickly, from the mechanical integrity system inspection work plans, launch a work order that once launched, you select the inspector that you want to assign the particular inspection to, and they'll get a notification on their tablet to start that inspection. They can do it in the field even without Wi-Fi. The application still allows you to go perform the inspection. As you can see from the second image, it'll even allow you to take pictures and append those pictures to the different sections within the report. And once the inspection is complete, it'll prompt the inspector out to perform a signature. And once the inspection is finalized, two things happen. One is that it gets automatically synced to the mechanical integrity system. So that asset will now basically have that inspection instance already stated in the previous inspections module that an external inspection was performed at that date. And at the same time, it automatically generates the full report. So there's huge time savings in not having to, come back to an office, put all of these images together as part of a PDF. As soon as you complete the inspection, it gets synchronized with the mechanical integrity system and automatically uploads that PDF report over to the mechanical integrity program. So it's a huge time saver when it comes to performing these inspections out in the field. And that sort of second part to the 50% improvement is just the ability of utilizing tablets out in the field and having access to the mechanical integrity suite system. Because once you complete this data migration process, you not only have access to your asset data, but you also have all of the asset files that come appended to that particular piece of equipment, like U1 documentation, construction documents, isometrics for piping circuits, and all inspection history records that might exist for those particular pieces of information, as well as all of your CML data, inspection plans, and even dashboards of information so that you can see the overall metrics of the plant. And it's all accessible via the mechanical integrity system. So those two items, the external visual inspections and the access to the mechanical integrity suite, are what are ultimately resulting in this 50% improvement when implementing our mechanical integrity software across these 8 sites.
Alberto, that was really good. I know you're going to talk about metrics, sure. But the ability to manage and understand the performance of people that are utilizing the technology and measure the performance of the technology itself and bring all that information back into leading and lagging indicators and the metrics. I know you're going to show that right now, but I think this integrating all of this together, especially the tablet, brings a lot of efficiencies that clients are looking to get. And if you can get 6 visual inspections done in a day as opposed to 4, and this information is coming from the client, it's coming from third-party inspection companies. So I think that's important to note as well.
Absolutely, yeah. Thanks for that comment, Ed. And yes, you clearly said this is another point that we want to close with, the metrics and the bulletin boards. I mentioned this at the beginning of the presentation, and essentially after everything was up and running, the 8 facilities were in production, we put this bulletin board together to enable knowledge sharing across the 8 facilities. This bulletin board showed a number of metrics that include things like leading and lagging indicators of risk, but it ultimately portrayed this information across the 8 sites. So personnel across the 8 sites could visualize what the activities were on the other side, see how many inspections were being put into the system, and even understand the improvements or bug fixes that were happening as part of the continued support from VisualAIM. So this second image that we have at the right, this is just a screenshot of a tool that we use on top of the mechanical integrity software. It's called UserSnap, and the way that it works is if a particular user either identifies an error or has a question or even a suggestion for the software, they can go ahead and just by clicking on this log UserSnap item, pinpoint within the software what their area of interest or question is, and kind of post that into the UserSnap system. And that becomes part of that accessibility or view throughout the bulletin board. So even the issues and the suggestions for improvements that the other facilities are making are visible throughout the 8 manufacturing sites. So this has really enabled that knowledge sharing across the 8 sites, and also with VisualAIM as well, to pretty much have more, if you want to put a word to it, a more harmonious and transparent view of what the other manufacturing sites are doing. And it just increased that knowledge sharing capability across the 8 sites. And that's something that, as I said, we did at the very end of the process to kind of increase that visibility for all plant personnel. So in conclusion, today we just kind of went over all of the lessons learned with respect to this data migration to our mechanical integrity system that we did across 8 sites, with the main point being obviously the knowledge transfer that we want to make sure that we transmit to our customer throughout the process to ensure and essentially increase the customer's confidence on both the mechanical integrity process that's being implemented and also on the technology itself. We also want to make sure, or one of the key points that we want to make sure come across is the fact that data validation is extremely important, especially when you're going from one version of the standard to another, or consolidating, as we did, different systems into a single one. So you want to make sure that data validations clearly take place and that the data gaps are closed as effectively as possible by the customer. All of this taking into consideration the human factor and being able to promote that knowledge sharing by the very end of the project, such that everyone has the ability to visualize what the other plant personnel are doing and share as well the items that they're finding, the suggestions that they're posting to the software, and ultimately understanding and being a part of the improvement of the overall system to make basically their work easier on a day-to-day basis. So that's what we wanted to share with you today. And this final point that we have over here of situational awareness, this is kind of like one final step that we went through with this particular facility, in which we implemented a separate solution that VisualAIM has. It's called the Intelligent Drawing Platform, which just increases the amount of situational awareness that you can get in your manufacturing sites by kind of integrating the mechanical integrity information with the visualization of the intelligent drawings. And we're going to go into a lot more detail with respect to this topic on our next session on Thursday. So we definitely invite you to join back in. That's going to take place this Thursday, the 24th at 4 p.m. Central Standard Time, and we'll talk a little bit more about it. But yeah, this concludes our presentation for today. And I just wanted to open up the panel. If anybody has any particular questions or comments, by all means, feel free to interject at this point.
Alberto, I just wanted to share with the audience as well that with respect to the intelligent drawing platform, one of the plant sites that were rolled out of the 8 that you talked about actually did implement the intelligent drawing platform and integrated it with the mechanical integrity suite. But they also integrated rotating equipment and pressure relief devices and instrumentation as part of that. So that was some added complexity, which I guess we're going to talk about more in detail on Thursday. But that was, and now that, and of course the client is also looking at migrating the intelligent drawing platform across the remaining 7 sites to achieve that situational awareness. And when we talk on Thursday, we'll talk a little bit about the value that we've measured and our clients have measured with respect to situational awareness and what that value proposition return on investment might look like. So I think that'll be an interesting discussion on Thursday as well.
Absolutely.